We will go further into the logistic functions mathematical part, which is also very important. Friends, to view this video, you must view the previous video so that you can have the better idea of what it is going on. You may further subscribe us, or you can also visit our blog and main website for more updates. Now, what is logistic or sigmoid function? If you look at this video, if you look at this slide, you could look that I have drawn a S-shaped graph in which the values lies between 0 and 1. So, this is a function which will transform the input values into a range that is 0 and 1. Okay, to undergo more, the logistic function is also called as sigmoid function, and mathematically f of x that is equal to 1 upon 1 plus e raised to power minus x, whereas x is a single input value that we feed to it. It could be one input variable. If x is infinite, if you do mathematics, fx is equal to 1, and if x is equal to minus infinite, fx is equal to 0. So it transforms the real value in range 0 to 1. If the value is greater than 0.5, the outcome is classified as 1, that is yes, else no. So yeah, I have not written the spelling of them correct. Just ignore it. The key points and observations. Two or more independent variables determine the outcome. That states that the predictors or the input variables. The outcome is measured with dichotomous variable. Dichotomous means two variables. The goal is find the best fitting model to describe the relationship between dependent and independent variable. So this is very common sense that what we need some relation between the input and output, and the function which gives us the relation between input and output is known as Logit function. So the Logit function gives the relation between the input and the output that we have seen in the previous video also. So now next slide. This is very important, that how the equation is derived for calculating the probability of the output. So from the previous video, you may have some knowledge of log and odd ratio. So in the previous video, I have shown with the examples how to calculate odd ratio, what is the natural log of odd, why the probability instead of probability the log of odd is used. It has the properties of linear regression, but it is not a regression model because the output is a binary, it's a classifier, it is not a numerical value. So everything that has been discussed in the previous video. So keeping this in the mind, let us derive the equation. It is simple math. The logit of P is equal to the log of odds. To calculate the log of odds, let us define the probability of success is P and the probability of failure is 1 minus P. So the logit of P is equal to the logit of P upon 1 minus P. How it comes? If you see the previous video, odd is equal to the probability of success upon the probability of failure. If P is the probability of success, the probability of failure states it is equal to 1 minus P. It is equal to B0 plus B1x. This is a linear relationship. If you go to the equation of a straight line, this is equal to y is equal to mx plus c. So this B0 is the intercept and B1 is the coefficient or the weight for a single value x. Taking antilog on both the sides, P upon 1 minus P is equal to e raised to power B0 plus B1x. Again, P is equal to, I am shifting the denominator to the right hand side. P is equal to 1 minus P multiplied by e raised to power B0 plus B1x. Again, P just multiplying the two values in the right hand side. P is equal to e raised to power, sorry, it's B0, not it's B1. You could correct it. It's B0 plus B1x minus e raised to power P into e raised to power B0 plus B1x. Now, taking the common values to the right hand side. So, P plus P into e raised to power B0x plus B1x is equal to e raised to power B0 plus B1x. Taking P as a common, the probability which is output, is equal to e raised to power b0 plus b1x divided by 1 plus e raised to power b0 plus b1x. So this is the real math which undergoes to calculate the equation of that. So friends, here just put it b0. It has been done by mistake. So please recollect it. Calculation. The coefficients are estimated using maximum likelihood estimation. Best values will provide a result closer to 0 or 1. Maximum likelihood tries to minimize error. B0 or B1 are calculated using above algorithm, and input value will be provided. So it is very easy to calculate the output using the equation. For example, you want to calculate the probability whether the person is a male or a female depends upon the height. So x is the height. Suppose x is equal to 100 centimeter, or for male I could estimate it 165 centimeter. So the value of x, you know, b0 and b1 will be calculated from the maximum likelihood estimation. You put both the values, you will get the probability. If probability is greater than 0.5, we say it is male. If the probability is less than 0.5, we say it is a female. So it is used for the categorical estimation, or it is used to estimate the class. That's why it's a classifier. So it is don't intercept it or interpret it as a linear regression model, because on the left hand side we do not use probability. Instead we use the Logit function, which is equal to the log of odds. So that differentiates it from its the probability. Okay. Now going further to the slide, why eliminate correlated inputs? This is a very important part while we are dealing with the input data. While the input data is fed to the machine, you should see that whether there are some columns where there is a number of zeros, or any columns, any two columns which are very correlated, just try to eliminate it before feeding to the model. Because if we are giving the correlated inputs, the model will undergo overfitting, and a lot of zeros or sparse condition or highly correlation will make the algorithm fails to converge. So these two reasons we need to eliminate the model. We eliminate the correlated values. Thanks for listening to the second video. Now, if you combine both the videos, you will learn some basics of the logistic regression. The first video was the base of probability, mathematics, odd and odd ratio. This video is more about the mathematics which was involved in the calculation of logistic regression and how it is differentiated from the linear regression. Thank you for watching this video.